Hello everyone, hope you are doing well. Let's solve LeetCode 39 combination sum. So the problem statement says you will be giving array of distinct elements and the target. Figure out the possible unique combinations where sum of elements is equivalent to target. One more key point is you can repeat the same element any number of times. If you see the input has 2 comma 4 and the target is 8, the possible combinations we can make as 4 twos and 2 twos with 1 4 and 2 fours. If you see each combination sum of elements is equivalent to target 8. It's a very good problem, can be solved with backtracking. So let's see how can we do that. We initiate a recursive call with empty list and the expected target is 8. So we have two possibilities. Either we can go with index 0 or index 1. Let's go with index 0. Index 0 has element 2. We add element 2 to the list. As we are including 2, so we remove it means we subtract the 2 from target. So the remaining target becomes 8 minus 2, which is going to be 6. Now, as the problem statement says, we can include the current element any number of times. So the consequent recursive calls starts from current index to n. So we again try to include 2. So now list becomes 2 comma 2. The remaining target will be 6 minus 2, which is 4. Now again we try to include 2. Now list becomes with 3 twos. Then target becomes 2. Now again we try to include 2. Now list becomes 4 twos. Now you see the expected target is 2 and we included 2. So the remaining target becomes 0. As the target is 0, we figure out a combination. It's time to clone the current list and add to the result, then return to the caller. As we updated the current list, so we remove the last element from the list so that you get a actual list which is initiated from the caller. From the caller, we are done with processing 2. Let's move on to index 1, which is having value as 4. So we add value 4 to the list. It becomes 3 twos comma 4. Expected target is 2, but we are considering 4. So the target becomes minus 2. As the target is negative, so we don't consider the current combination. So we just returning to the caller by removing the last element from the list. So with this, we are done with all possibilities from current caller. So return to its parent by removing the last element from the list. So you will again get 2 comma 2. Now from the caller, we are done with processing 2. Let's move on to 4. So we try to add 4 to the list. It becomes 2 to 4. Expected target is 4 and we are including 4. So the remaining target becomes 0. We figure out a combination so that we clone the list and add to the result. That's it. Then we return to the caller by removing the last element. We'll again get same list. So from the current caller, we are done with all possibilities. Return to its parent by removing the last element. You will get list with value 2. Now in the caller, the expected target is 6. Now we go with adding 4. So it becomes 2 comma 4. Remaining target becomes 6 minus 4, which is 2. Again we try to include current element, which is 4. List becomes 2 comma 4 comma 4. Expected target is 2, but we included 4, so the target becomes minus 2. As the target is negative, we ignore the current combination, return to the caller by removing the last element. So from the caller, we are done with all possibilities. So return to its parent. Then if you closely see from the caller, we are done with all the possibilities. So return to its parent. By removing the last element, you will again get empty list. So with this, from main caller, we processed with index 0. Let's move on to index 1, which is having value as 4. So we add 4 to the list. So list becomes 4. Now expected target is 8. We included 4. So the remaining target becomes 8 minus 4, which is 4. Again we try to add current element. So here the list becomes 4 comma 4. Expected target is 4. We added 4. So the target becomes 0. So as the target is 0, we clone the current list to the result, then return to the caller by removing last element from the list. With this, from the caller, we are done with all possibilities. We return to its parent by removing last element from the list. That's it. That's how we figure out all the possibilities where the sum of combinations is equivalent to target. It's a simple recursion flow with backtracking. So let me walk through the code. If you closely see, our backtrack method includes 5 parameters. One is index and the input array, and we have a list which is maintained across the recursion flow, and the target. Finally, we have a result. As a base case, whenever our target becomes less than 0, we just return to caller. Whenever our target is equal to 0, we figure out a combination so that we clone the list, add to the result, then return to the caller. And we initiate a start index as current index, and we move till the end, and for each time we just increment the start index. So one important point is we add the current value to the list, then we initiate a backtrack call with current index, which is start index, and on backtrack call we subtract the current value from the target. That's it. Once we are done with recursion flow, so while returning to the caller, we remove the last element from the list. So that's it. It's a simple code. If you don't get this code, don't mind. Please go back and watch the recursion flow one more time. You will get more clarity. If you closely see, our backtrack method always initiate a call with current index, which is start index. On recursion flow, we are always updating the target value as target minus current value. And whenever your target becomes 0, we clone the list and add to the result. So let's go and understand the time complexity. Here the time complexity is a little tricky to understand. Don't apply too many mathematics on it. Simple common sense can give the better understanding. If you closely see, we have an input 2 comma 4 and the target 8. So these are the combinations we made. So we made 4 twos and 2 twos with 1 4 and 2 fours, right? So if you closely see, our maximum depth of a recursion tree is 5. So how can you calculate a max depth? The max depth is equivalent to target by minimum element in an array plus 1. So which is going to be 8 is the target, minimum element in an array is 2, 8 by 2 plus 1, which is equal to 5. So on an average case, for n elements present in an array, there is a possibility that we can move on to max depth. So the time complexity becomes big O of n to the power of target by minimum element plus 1. That's it. So when it comes to space complexity, we don't consider the result. We consider how many stack frames are getting active within our algorithm. In this case, total stack frames are active at any point in time is 5, which is equivalent to target element by m plus 1. It means minimum element plus 1. So the space complexity will be big O of t by m plus 1, but we can ignore that plus 1. That's it. So let me go and submit the code. If you closely see, we have a empty result and we initiate a recursive call with empty list, target and the result. Index is starting from 0. The base case is whenever our target is less than 0, we just return to the caller. Whenever our target is equivalent to 0, we figure out a combination so that we clone the list, add to the result, then return to the caller. And we initiate a start index as current index. So we add the current element to the list. Then we initiate a backtrack call with the same start index by updating the target as target minus current value. Once we are done with recursion flow, we just remove the last element from the list. That's it. So let me go and submit the code. So that's it. So we are done with the submission. It took only 3 milliseconds. Hope you like the explanation. Please do subscribe and share. Thanks for watching.